In last video related to the Poisson distribution, we have discussed how to use Poisson distribution for calculating estimated frequency with the and for comparison with the original frequency and estimated frequency. We have done some question related to the Poisson distribution. In today's video, we will having discussion on the constant values of the Poisson distribution. On the Poisson distribution, if we want to calculate arithmetic mean, that is called m. For getting m, we are having sigma fx or sigma f or having np. For calculating arithmetic mean, we can use np. The very first question is over there. For getting constant of the Poisson distribution, the very first, for getting the arithmetic mean, we will use the formula arithmetic mean, that is arithmetic mean is equal to sigma fx divided by sigma f, and that is np. So m is equal to np for the arithmetic mean. Second, the standard deviation is npq. In Poisson distribution, q is 1 approx. Already we have discussed in our last one video. So the standard deviation will be np, and np value is m, so the standard deviation will be under root m. This is first formula, this is second formula. And for variance, that is standard deviation square, will be npq. Q is equal to 1, so standard deviation square, that is np, or standard deviation square is also m. So if we want to calculate arithmetic mean, then we will use np. For standard deviation, that is root m. For variance, that is m. It means x bar is equal to standard deviation square in Poisson distribution. This will be. Now for other measures of the Poisson distribution, these are the three measures of the Poisson distribution, that is arithmetic mean, standard deviation, and the variance. If we want to calculate skewness, measures of skewness, that is fourth. That is 1 upon under root beta 1. Sorry, that is beta 1. That is 1 upon root m. For getting the value of skewness, the formula will be under root 1 upon m. And measures of kurtosis, beta 2, that is 3 plus 1 upon m. The formula is for 3 plus 1 upon m. So the very first, againly I should repeat the constant value of this Poisson distribution. First one, see, then we will having some question related to this. First one, if we want arithmetic mean, m is equal to np. So x bar is equal to m, or m is equal to sigma fx upon sigma f if f and x is given, no problem at all. Second one, standard deviation is npq, and q approximate 1 is over there, so standard deviation will be np, and np is equal to 1, so standard deviation will be root m. Third, standard deviation square, it means variance, that is npq, and q is equal to 1. So the standard deviation square will be np, or we are away standard square is m. Fourth one, that is called skewness, that is beta 1, that is 1 upon root m. And fifth one, that is kurtosis, measures of kurtosis, beta 2, that is 3 plus 1 upon m. This formula we will use 1, 2, 3, 4 and 5th. This formula we will use for calculating constant value under Poisson distribution is over there. So I think you may be learned how to calculate constant value in Poisson distribution. We are having some questions related to this. So it will make you a confidence how to use this formula. So one question. In a certain Poisson distribution, the frequency corresponding to 2 success is half of the frequency corresponding to 3 success. Find the mean and standard deviation of this. Here in a Poisson distribution, the frequency of 2 success is the half of the frequency of 3 success. So then find the arithmetic mean, standard deviation and variance of this. In a Poisson distribution, the probability of 2 success is a half of the probability of 3 success. So probability of 2 success, probability of 3 success in half. What the question is saying, in a Poisson distribution, the probability of 2 success is equal to the half of the 3 success about there. So 3 success half is over there. So that is formula is for this, that is n e raised to power m raised to power x upon factorial x. So we are writing n e raised to power m raised to power 2 upon factorial 2, that is n e raised to power minus m raised to power 3 upon factorial 3. N to n cancel, e raised to power this cancel. So m square upon 2 is m raised to power 3 upon 6. So m squared this and this is for 3. So m is equal to 3. So the arithmetic mean for this is 3. Standard deviation of this is root 3, root m. So standard deviation is root 3. What the very first you should learn. The probability of 2 success is equal to the half of the 3 success. So we are having, this is half. So we are having n to n cancel, e raised to power m to m cancel. So m raised to power 2 upon this. So here, from here you should learn more. Okay. So now m square factorial 2, that is 2 into 1. This is m cube factorial through, that is 3 to 1. Okay. 2 1 to 2 1 cancel. M raised to power 2 cancel to this. So 1 is equal to m by 3 and m is equal to 3. So we get the value m is equal to 3. First we have get. Now if we want to calculate constant value, how we will calculate constant value? Later we will see. First constant value is x bar is equal to m. So x bar value m is 3. Second constant value, standard deviation is root m. So standard deviation, we will get the root of 3 root 1.732. Third measure, that is variance, that is m. So the variance value will be also 3. Fourth is measures of skewness, that is beta 1, that is 1 upon root m, that is 1 upon 1.732. 0.577. Fourth one is beta 2, that is kurtosis, 3 plus 1 upon m. So 3 plus 1 upon 3, that is 3 plus 3. So with the help of this, we can calculate the various measures of the Poisson distribution: arithmetic mean, standard deviation, variance, measures of skewness and measures of kurtosis. Now second question. So with the help of this video, you may be learn how to calculate the various measures of the Poisson distribution. In a Poisson distribution, the arithmetic mean is 2.56. Calculate other measures of the Poisson distribution. What the question is saying, in a Poisson distribution, the arithmetic mean is given 2.56. Calculate the other measures of Poisson distribution. So here the first one, arithmetic mean, that is m, and that is given arithmetic mean m is given 2.56. Second, we can calculate standard deviation, that is under root m. So 2.56 under root, that is 1.6. So standard deviation, that is 2.56 or having 1.6. Third measure, standard deviation square, that is variance, that is 2.56 because m is 2.56. Fourth measure, that is measures of skewness, that is 1 upon root m. So that is 1 upon 2.56, we are writing 1 upon 1.6. So 1 divided by 1.6, 0.625. So there will be 0.625. And fifth measure, that is measures of kurtosis, that is beta 2, 3 plus 1 upon m. The formula for the beta 2, that is 3 upon 1 plus m. So 3 plus 1 upon 2.56. So we are having 1 divided by 2.56 plus 3. So that is 3.39. So with the help of this, we can calculate all measures of the skewness Poisson distribution. If the value of m is given, then m is arithmetic mean, then root m is standard deviation, then m is variance, then beta 1 is 1 upon root m, that is called measures of skewness, and this is measures of kurtosis is over there. So direct question may be also in this form. Third question, in a Poisson distribution is given Px बराबर 1 is equal to Px बराबर 2. For a random variable x, follow the Poisson distribution such that Px बराबर 1 is equal to Px बराबर 2. Then calculate mean and variance of the distribution and also find Px बराबर 0 or Px greater than 0. Px बराबर 0 to calculate, Px greater than 2 is to calculate. Okay. In a Poisson distribution, Px is equal to 1 is equal to Px is equal to 2. So here n e raised to power minus m, m raised to power 1 upon factorial 1 is n e raised to power minus m, m raised to power 2 upon factorial 2. N to n cancel, e raised to power m to m cancel. So m by 1 is equal to m square by 1 multiply 2. M to m cancel, so m is equal to 2. So the arithmetic mean is m, that is 2. Variance square, that is also m, that is 2. So already we have calculated. Now we are to calculate Px is equal to 0. That is e raised to power minus m, m raised to power 0 upon factorial 0. So we are to calculate e raised to power minus 2, 1 upon 1, that is e raised to power minus 2. So we will calculate the e raised to power minus 2 value. That is 0.1353, 0.1353. 0.1353, e raised to power minus 2, that is 0.1353. So this also we have calculated. Now second, x greater to 2, x greater to 2, it means that may be 0, that may be 1. What is x is greater than 2? For getting x is greater than 2, okay. We are to calculate greater than 2. So that x is 2 and Px greater than 2, that is 1 minus x equal to 0 plus x equal to 1 plus x equal to 2. If we will deduct from 1, x is equal to 0, x is equal to 1, x is equal to, so remaining will be greater than 2. So we are writing here p x is equal to 0, that is 0.31353. This is x is equal to 0, we have calculated. P x is equal to 1, that is e raised to power m raised to power 1 upon factorial 1, that is 0.1353 multiply 2 upon 1, because m value is 2. Already we have calculated value of m is 2. This is m is equal to 2. So the second value 0.1353 multiplied by 2, 0.2706. So that is 0.2706. So that is 0.2706 and plus px barabar 2, that is 0.1353 multiply 2 raised to power 2 upon 2. So 0.1353 multiply 2, that is 2706. This is also 0.2706. So greater than 2, we will add this all. 0.2706 plus 0.2706 plus 0.2706, that is 6765. So 0.6765. So 1 minus 0.6765, 0.2706 1 times, 2 times, 0.1353 1 times. So this is 0.2706 1 times, 2 times, and 0.1353 1 times. So this 0.2706 1 times, 2 times, and 0.1353, that is 0.6765. So 1 minus 0.6765, so that is 0.3235. So in this question, what very first we have done, px barabar 1 is equal to given px barabar 2. So we have calculated the value of m is equal to 2. So e raised to power minus m, e raised to power minus 2, that value is 1.353. Okay. Then if x barabar 0 is to calculate, so x barabar 0, e raised to power minus m, m raised to power 0 upon factorial 0, that is 1.35. Then that they ask that p greater than 2. So 1 minus greater than 0 equal to 0 equal to 1 equal to 2. If deducted from 1, we will get that is greater than 2, that is 0.3235. So in this manner, if Poisson distribution question is over there, then also you can solve the question, no problem at all. One more question related to the Poisson distribution we will discuss in this video. This is last question in this video. Later we will having another one video for calculating another Poisson distribution is over there. The question is this: in a Poisson distribution, question is given x follow the Poisson distribution which p x बराबर 2 बराबर 9p x बराबर 4 प्लस 90p x बराबर 6. Then calculate mean and variance. X follow the Poisson distribution and equation is px बराबर 2 is equal to 9px बराबर 4 plus 90px बराबर 6. Then calculate arithmetic mean of this, standard deviation of this, and standard deviation square of this. So here n e raised to power minus m raised to power 2 upon factorial 2, that is n e raised to power minus m raised to power 4 upon factorial 4 plus 90 n e raised to power minus m m raised to power 6 upon factorial 6. So n e raised to power minus m common, so this will m square also come. So this will be 1 upon 1 multiplied 2. Here n common, e raised to power minus m common, m raised to power 2 common. So this will be 9. This common, 9m square upon 24. That is 90m raised to power 4 upon 720. What we have done? Px बराबर 2, so n e raised to power minus m raised to power 2 upon 2, that is 90 n e raised to power m raised to power 4 upon 4 and n raised to power 6 upon 6. Common, n to n cancel, e raised to power m to e raised to power m cancel, and m square to m square cancel. So that is 1 by 2 3m square upon 8 plus 9 8 ja 72. So m4 upon 8. So getting the solution, 3m square plus m4 upon 8, that is 1 upon 2. So that 4. So we are having 3m square plus m4 is equal to 4. 3m square plus m4 is equal to 4. Now we will get the solution of this. We will get the solution of this. So m4 plus 3m square minus 4 is equal to 0. So m4 plus 4m square minus m square minus 4 is equal to 0. So m square common, m square plus 4 minus 1 common, m square plus 4 is equal to 0. M square plus 4 common, so m square minus 1 is equal to 0. If m square plus 4 is equal to 0, so the m is equal to minus 2, not possible. M square is equal to 1, so m is equal to plus 1 or minus, m is equal to 1. So the value of m is equal to 1. What we have done? Firstly, we have solved this question. Later, this m4 plus 3m square is minus 4 is equal to 0. So m4, division of this m4m square minus m square minus 4 is equal to 0. Common getting. So 1 is m square minus 4 is equal to 0. So m square will be minus 4. That is not possible. Second value, m square minus 1 is equal to 0. So m square is equal to 1. So m is equal to 1. So it means the value of m is equal to 1. Now we have got the value of m. So m is equal to 1. So x bar is equal to m is equal to 1. Standard deviation is equal to root m, that is root 1, that is also 1. Standard deviation square, that is m. So standard deviation square is so also 1. If they want beta 1, that is 1 upon root m. So that is 1 upon root 1, that is 1 upon 1, that is also 1. If beta 2 is required, 3 plus 1 upon m. So 3 plus 1 upon 1, that is 4. So with the help of this, we can calculate all the value related to the Poisson distribution. So with the help of this video, I think you may be learn how to calculate the question related to the Poisson distribution is over there. How we can calculate the constant value in Poisson distribution. Thank you for watching this video. If you will go with me, you will certainly know how to calculate this all statistics is over there. If you are having in Hindi medium also some different playlist is also available in which the Hindi medium statistical question is given. Thank you once again for watching this.